Prajakta, please take screenshots also if there is certain problem. In that case, we can compare both.
Okay, ma'am.
Okay, I think my screen is visible.
Yes, ma'am.
Okay. So we have completed sequential statements. Then after that, we have completed concurrent statement also, and then we are proceeding forward uh, towards the subprograms. Now, what is subprogram? So that we will discuss, and then different types of subprograms that we are going to see in this lecture. Okay. So as we are discussing basics of VHDL programming only, because whenever we want to write a program, we should know ABCD of that. Okay, and that we are learning right now. So what is there? What are the components in that we are discussing in this first unit? That is the introduction to this EDA tool and VHDL programming. Okay, so in that now we are going to discuss about subprograms. Now, what is meant by subprogram? It is the uh, sequential algorithm that performs certain computations and executes it in a zero simulation time. Okay, so this subprograms that consist of procedures and functions that can be invoked repeatedly from different locations in VHDL descriptor. Okay, that means we can call subprograms from any location in the program that we are using right now. Okay, so there are two types of subprograms. One is the function and another one that is a procedure. Now, what is function? They are usually used for computing a single value. So whenever we want to compute any single value, that time we use functions. And procedures, these are used to partition large behavior description. Okay, that means if your program is very large and there you need to do a very large description, in that case you can partition that into small procedures, and then you can call it in a main program body. So these procedures that can return to 0 or more values. Okay, so as here subprogram, these are the programs, small programs that consist either procedures or functions, and that can be called in a VHDL description. Okay, so now we are going to discuss about this functions. Okay, but before that, okay, uh, subprograms, uh, in a subprograms, actual values that are passed to and from a subprogram via a subprogram call. Okay, so remember that we can call actual values uh, or we can pass these actual values to the subprogram or from the subprogram via a subprogram call, which will be in a main program. Only a signal object that may be used to pass these values. Okay. Uh, then the type of actual value in a subprogram call that must match that of its corresponding formal parameter. Okay, so that is a very important point, that the type that must match. Okay, and then the return statement that will cause the subprogram to terminate. Okay, so there will be a return statement which will be present in a subprogram, which will cause termination of that subprogram, and then control will be returned back to the calling object. That means the program which is calling that subprogram. So the control will be passed to that object. Okay. So here now we are going to discuss about functions. Now functions are used to describe frequently used sequential algorithm that return to a single value. That means suppose you want to call and or you want to use and gate, okay, so many times. So instead of defining it all the time in a program, you can have a function for that. Now this AND gate, that is a inbuilt function in a IEEE library, but similar type of you can do whatever function or whatever algorithm you want to call so many times, that you can write as a function. Okay, so this value is written to the calling program using a return statement. So whenever you evaluate this or execute this function, after that this whatever result is there, it will be written to a single value, and that value is returned to the main program using a return statement. That means in a function, this return statement, that is important. Now in these functions, these are invoked as expressions, and as I earlier said, that always return to just one argument, that means one value. All parameters of function that must be of a mode in. Okay, so that means all parameters that we are using in the function, that must be of a in type. Okay, all signals, and then all parameters of function that must be of class of signal or constant. Okay, that means either that parameter that could be a signal or constant. Then it must declare the type of the value it returns. As VHDL is a strongly typed language, and that is why it must declare the type of the value that it returns. And then it cannot contain wait statement. This is again important point, that this function cannot contain wait statement, but it contains sequential statements. Okay, so in a function we have sequential statements, and function can convert one type to another type. So there are some built-in functions that are available, or some user supplies and reuse. Okay, and there is no side effects of the when we are using functions. That means there will not be any effect on the main function working when we are calling functions. So if we look at the syntax of this function, here you can see this is a function keyword, then identifier, interface list, identifier, then interface list, then keyword, that is a return, and then type mark is. Okay, this is a keyword again. Then there will be a declarative part that will be present, and after that begin keyword, and which will be followed by sequential statement which will be present in that function. Okay, and then at the end there will be end of this function, and again in the bracket there is a word that is identifier. That means end will be followed by the identifier or the name that you are giving to this function. Okay, so that will be present here. This is the optional. If you want to write it, or if you want to have it, then only it will be present. Otherwise no need to write it. You can just simply put a keyword, that is the end and semicolon. पण जर तुम्हाला ते यूज करायचं असेल तर त्याचं नाव हे सेम इथे जे तुम्ही यूज करणार आहे तसंच असलं पाहिजे. Okay, so the identifier defines the name of the function, and interface list defines the formal parameters of the function. So here whatever this, there are parameters that are present in this function that will be declared with this interface list. Each parameter is defined using the syntax which will be followed in the next slide. So it is class, that means the class of the object which could be a constant or signal, then name list, then mode of that class, and then type name, and then expression. Okay, so here mode of the object must be in. Okay, as functions uses only mode in, so this mode that should be always in, and if no mode is specified, the parameter is interpreted as mode in. That means here, as this mode is in a square bracket, So इट इज ऑप्शनल. ओके, सो जे काही स्क्वेअर ब्रॅकेट मध्ये आहे ते ऑप्शनल आहे. तिथे तुम्ही नाही लिहिलं तरी चालणार आहे. म्हणजे जर तिथं स्पेसिफाय नसेल केलं इन म्हणून तर तो ऑटोमॅटिकली इट विल बी कन्सिडर्ड ॲज अ मोड इन. अँड इफ नो क्लास इज स्पेसिफाईड, parameters are interpreted as class constant. Okay, so here there is a one example where we are calculating a certain function. So here you can see that this is a function. Okay, so in a process we are writing this function. So this function is c to f. Okay, where this c which is the object that or the parameter that we are calling, so that is a real, and then return real is so name of the function that we have used is a c to f. Okay, and the parameter that is a c which is a real, and then return real is variable. Okay, so that we are declaring here, that is a of real type. Okay, then begin. So the here this function will begin. Here we are calculating this f, that is equal to c into 9.5 divided by 5 plus 32. Okay, so here as by default it will be understood as this c is a constant. Okay, here as we have not specified the class, so it will be constant. Again, as we have not specified mode also, that means it will be again in mode. Okay, and then it is a real time. So then after this calculation, it will return to f. Okay, so this will be returned. So end of this c to f. म्हणजे ही f ची जी काही व्हॅल्यू असणार आहे ती कुठे जाणार आहे, मेन प्रोग्रामला जाईल. When we are calling this. Okay, so now after this in the begin statement, in the process we are calling this c2f. So there we are using c2f of 5.0 plus 20. Okay, that means now here this value of c that will be taken as 5. So after calculation, what will be value of temp here? And then end of process. म्हणजे इथे आपण काय करतोय, टेम्प साठी आपण c2f हे फंक्शन कॉल करतोय. जे फंक्शन काय करतंय, f ची व्हॅल्यू कॅल्क्युलेट करतंय. That is a c into 9.0 divided by 5.0 plus 32. So now if the value of c that is equal to 5.0, so what will be value of temp? काय करेल तो इथे? How this program will get executed? So whenever we are having this here, this will call this function c2f, and then it will from this value where c, this will calculate this f value. So what will be the value of f now, which will be returned to main program? काय व्हॅल्यू रिटर्न होणार आहे मेन प्रोग्रामला? 5 multiplied by 9 divided by 5. That means it will be 9 plus 32. That means it will be equal to 41. So the value of f which will be returned to this main program, that will be 41. 41 plus 20, that means it will give us the value of 10, that is equal to 61. Okay. So now we can call this function anywhere in the program, okay, or many times in the program. So that is the use of this subprogram or in the functions. Okay, but now this function you can see here that it is returning to a single value only. Okay, next type of subprogram, that is function, procedure. So this procedure that allows decompositions of large behaviors into modular sections. That means actually we can divide a large behavioral statements into small ones, and then we can write a procedure subprograms there which are called as a procedures. Okay. In contrast to functions, these procedures can return either to 0 or more values using parameters of mode out and in out. That means in a procedure, parameters may be of a mode in, then it may be of mode out and mode in out. Okay, only buffer mode that will not be present, but otherwise these three modes that will be present in a procedure. Okay, then these are called as a statements. It can return, as I earlier said, it can return to none, one or more argument or more parameter values. And all these parameters that are of the class signal, then constant and variable. Okay. In functions, we are having just class of signal and constant, but in procedures, it may be also of a variable type. Then it may contain wait statement. Now, as functions cannot have wait statements, but procedures can have wait statements. Okay. The syntax for this procedure, that is a keyword procedure, then there it will be followed by identifier, and then there will be interface list. That means there will be parameters. Then there will be a keyword is, and after that there will be subprogram declarative item. That means whatever declarations we want to do, that could be present here. Okay. Then after that there will be a begin, so it will be start of this procedure, and then it will be followed by sequential statements, and then end of this procedure. Okay, so here you could have the name which you have specified here, that is the identifier. Okay, so as here this identifier that defines the name of procedure, and interface list that defines the formal parameters of this procedure. Okay. Now each of these parameter is defined using the syntax, that is class, then name list, then after that mode, then type name, and then expression if it is present. Okay. So this is the syntax for the parameters. Okay. Then here the class of the object that refers to either constant, variable or signal. Okay. And mode of the object, it may be in, out or in out. If no mode is specified, okay, so then it will be interpreted as a mode in. Okay. But otherwise, if you want to specify out mode or in out mode, then you have to specify it clearly. If no class is specified, parameters of mode in are interpreted as class constant. Okay. And parameters of mode and in out are interpreted as being of class variable. So here you, if you are not mentioning proper type as well as proper class, then there may be error that will be present. So if it is of a variable type only, then only you can skip it out and in out mode. Otherwise, you need to clearly mention that class as well as mode. Okay, so remember this point. Now let us have one example. Now, do you know how to check parity? What is mean by parity? Parity check. When we call it as it is of a even parity.
When in a given bit, number of ones are even.
Yes, if the number of ones are even, then we call it as a even parity. Okay, and if it is of number of ones that are odd, then it is a odd parity. So now we have this same program for this parity check. Okay, so here we are writing a procedure. Okay, so how we are going to check a parity? that will be one procedure, and then we are calling this in a main program. Okay, so here actually this is a architecture of behavior of receiver. Okay, so certain program the which is we are defining in a process. So for that we have I'm discussing first this part, that is a architecture part of the behavior, and then we will go to the parity. Okay, that is the procedure. So here this architecture that is has the very process which is variable, having variable that is of top, bottom, odd, dummy, and then all are of a bit type. Okay, and then variable y which is a bit vector which is 15 down to 0. Okay, then after that there is a begin statement, that means it will start off this process. There may be some sequential statements that may be present, which I have not mentioned here. But after that, I'm calling this a parity procedure. Okay, so here this parity, for that, first of all, I have considered only 8 bits, that means from 7 down to 8, that are considered, and then uh, it will return whatever value that is returned from the parity procedure, that will be returned as top and dummy. Okay, then again I have called the same procedure, and for here we have considered next 8 bits, that is 7 down to 0, and the result of this parity procedure, that is will be present in this program as a bottom and dummy. Okay, so here now let us go what we are doing in this parity. Okay, so here we have declared this procedure which is named as a parity, where we have a parameter that is a which is input type, and it is a bit vector from 0 to 7. Now, do you know logic behind how to check parity? मला जर पॅरिटी चेक करायचं असेल तर त्याच्यासाठी मला काय करायला लागेल? If I go
मॅम
on,
जेव्हा आपण
yes.
मॅम जेव्हा आपण सिग्नल सेंड करतो तेव्हा आपण त्यातले नंबर ऑफ वन्स चेक करायचं. जर ऑड असतील तर त्याच्यामध्ये प्लस म्हणजे 1 ॲड करायचं आणि ते सिग्नल सेंड करायचं. आणि जर रिसिव्हरला जर सेम म्हणजे नंबर ऑफ वन्स आर म्हणजे सेम आले तर आपलं सिग्नल हे करेक्ट आहे. जर नाही आले तर सिग्नलमध्ये आपलं सिग्नल इज डिस्टर्ब.
येस, ओके, वी आर नॉट गोइंग इन दॅट डिटेल्स राईट नाउ. मला फक्त काय चेक करायचंय की तो ऑड आहे की इव्हन आहे, म्हणजे त्याच्यानंतर मी पुढचं प्रोसेस करणार आहे, बरोबर आहे. पण आता मला सध्या काय करायचंय की ती ऑड आहे की इव्हन आहे. मग मी हे चेक कसं करणार की जे माझ्याकडे डेटा आहे किंवा जो माझ्याकडे आता वेक्टर आहे, माझ्याकडे वाय हा बिट वेक्टर आहे ज्याच्यामध्ये 16 बिट्स आहेत, दॅट इज 15 डाऊन टू 0. मग मी डिवाइड काय केलं ते 8 बिट मध्ये केलं, कारण मी माझा जो प्रोग्राम आहे तो काय केलाय, म्हणजे प्रोसिजर आहे ते मी काय केलंय 8 बिट साठी डिफाईन केलेले आहे. ठीक आहे, आता याच्यामध्ये मला मग ह्या 8 बिट मध्ये किती बिट्स आहेत, इव्हन आहेत की ऑड आहे, 1 बिट इव्हन आहेत की ऑड नंबर मध्ये आहेत हे मला चेक करायचंय. तर त्याच्यासाठी मला काय करता येईल, okay, so what logic we could use to get whether the number of ones that are present in my vector that are with even numbers or odd numbers. So for that we can use XOR gate, okay, or XOR. So as we know that if in a XOR, if both the inputs that are either high or low, we get the output that is 0. If any either of inputs is 1, then only we will get high input. Okay, so that logic we can use here. And then for this we have using one temporary variable, that is a temporary parameter, that is a 0. Okay, so which has the value that is 0. Okay, and then here for loop is used for I uh, in that is the range of this I, that is from 0 to 7. Okay, and then that is a loop use, and then this temporary parameter that is assigned to the value, that is a temp XOR with a of I. That means here each of this bit that will be considered from this a vector. Okay, and then there will be end of loop. आता हे जर केल्यानंतर मला काय रिझल्ट मिळेल, म्हणजे माझ्याकडे जो काही वेक्टर जे काही डेटा अवेलेबल आहे, म्हणजे बिट्स अवेलेबल आहेत, त्या प्रत्येक वेळेला काय करणार आहे, जो टेम्पचा आधीचा रिझल्ट आहे त्याच्या बरोबर एक्सऑर करेल. ओके, नाउ सपोज वी विल टेक ओनली 2 बिट्स. ओके, सो आता फक्त त्याच्यासाठी एक्झाम्पल साठी मी 2 बिट डेटा घेते. समजा माझ्याकडे डेटा आहे 0 1. ओके, सो व्हॉट इट विल डू, now this loop will be evaluated for 2 times. Okay, now for the first time it will have the a of I that is equal to 0, and then it will be XORed with 0. So I will get result as a 0 XORed with 0, that means 0. So the new value for temp that will be 0. Now for the second time this for loop will be evaluated, and then now my a of I that will be having value 1. So it will be XORed with the temp value, that is a 0. So 0 XORed with 1. So that will be 1. And so the new value that will be equal to 1. Okay. So आता माझ्याकडे किती होते, 2च बिट्स होते, आणि त्यामुळे त्याच्यामध्ये काय होतं, एक काय आहे की एकच 1 आहे, म्हणजे ऑड पॅरिटी आहे. सो माय रिझल्ट that will be temp that will be equal to 1. Okay, so here this function that will be evaluated in the similar way, and then depending on that I will get the result at the output. Okay, so now you can check it for number of bits also. So and then for like this way, and then you can get the result. Now this result that will be stored as this temp value that will be assigned to result 1 output, and not temp that will be assigned to result 2 output. Okay, now this value, whenever we are calling this procedure in a main function, that time this value will be returned to procedure. Okay, depending on whatever parameters are available here. So now whenever we are calculating these many this function procedure, that time this temp value will be written as a top, and this result 2 which will be written as a dummy value. Okay, so similarly it will function for the next procedure. Okay, so number of times we can have this procedure that can be called in a main program. Okay, so you can write any procedure and that you can call in a your main program. So that is about the procedure that we are using in a VHDL programming. Okay, so similar type of functions and procedure that you must have used in a C programming while learning C and while learning data structures. Okay, so this language, VHDL language, is in that way very simple to understand, because it is like a you can write this program in a very simple way. So now this functions and procedures, we need to store it at certain common place. Okay, and so we need to create a package to store common subprograms, then common data types and constants, etc. So that we can use more than one design, more than one design. Okay, so that means suppose whatever parity procedure that we have seen earlier, I want to use it in so many programs. Okay, so if I store it in certain package, then I can call that package, and then while using the library. Okay, so there also, if I call that package, then I can easily use that sub program in that program. So this package that consists of two parts, that is, one is the package declaration section and another one that is a package code. Okay, we have already discussed about these packages when we discussed about library, but still in continuation with this sub programs, I am again discussing about this part. So the package declaration that defines the interface of the package, and for this syntax is package, then after that package name is, then package declarative item, and then end of that package. So there will be a package name. Okay, then in this package body, that is the dependent unit of this package. Okay, so it is used to store details of objects that are declared in the package. This also includes subprograms and algorithms, and then functions, all that you are going to use or you are going to store in that package, that will be present in a package body. So here this package, it will have the name, then is, and then all the constant functions, components, subtypes, whatever you want to declare, that will be present here. So that is the declaration part, and then after that, in a package body, you have to whatever name that is given, that will be there, and then is, and then all that things that you want to stored in that package, that will be present in detail in this package body. That means the functions that you want to store, then processes, then component types, sub, procedures, all that will be present in this package body, and then there will be end of that package body. And now this package you can call in any program. That means actually you need to declare this package while declaring the libraries and then packages, and then after that you can use this all these functions which are stored in that package in that program. Okay, so that is about the package body. Then after that we are going to see about the what is overloading. Okay, now you can use a same name for different objects in VHDL program. So now this is very convenient to use same name to store to use it for more than one program, because we need to give a name, okay, unique name to each of this subprogram, and finding a unique name, that is a little bit difficult, and that is why if we are using the same name, then that could be easier to us. Okay, and this facility that is provided by the VHDL programming, that we can have a overloading, so we can use same name for different objects. Now there are two types of overloading. Okay, one is the subprogram overloading, and another one that is the operator overloading. So if we are giving a same name to two or more subprograms, then we call it as a subprogram overloading. So in each case, the subprogram name, so in such case, the subprogram name is said to be overloaded. Now, for example, suppose we have two declarations. One is the function count, and then parameters are oranges, which are of integer type, and then return integer. Then function count. Okay, so this is another declaration. Function count apples, which is of bit type, and return to integer. Now here you can see that we have one function which uses the integer type of parameters, while another function that uses bit type of parameters. That means these two functions are not same, but still we have given the name count to both these functions. Okay, so here That means these both functions are overloaded functions. कारण का, कारण या दोन्हींचं नाव काय आहे, सेम आहे, पण आणि काउंट असं, आणि त्याच्यातले पॅरामीटर्स जे आपण यूज केलेले ते मात्र डिफरंट टाइप्सचे. ओके, सो when a call to either function is made, it is easily possible to identify the exact function to which the call was made from the type of actual parameters passed. Okay, so if we want to make a call for either end of this function, then it will be possible to identify, because whenever we are calling that function, we need to specify the parameter in there. Okay, so suppose we are calling the function called count, in the bracket there is a 20. Now this 20, that means it is an integer type, so it will call to this function. Okay, so that is a count, oranges integer. For this function it will call. Okay, now suppose we have the another function call, that is a count, in the bracket in single quote 1. Okay, now if we are writing this in this type, then it is clear that the parameter that we are using, it is of a bit type, so it will go to the function that is a count function. Okay, so this count function, it will not go to this another count function. Okay, so this is a subprogram overloading. That means here we are giving the same name to more than one program. Okay, then another type of overloading, that is operator overloading. Here operating overloading, again it is the useful feature in this language. The operator is called overloaded if there is more than one function specifying it for different data and result types. Okay, VHDL allows defining operators of the same names as predefined operators, but for different operand types. Both can exist together in one specifications, offering greater versatility to the user, and all synthesis tools that provide a package which contains overloaded operators and functions. Okay, so here also again we can have a overloaded operators. That means the operators that we are using in VHDL, that could be used for more than one function. Okay, so typically they include the operator that is a plus, minus, equal to, not equal to, then less than or equal to, greater than or equal to, less than or equal to, greater than or equal to, and then which are the overloaded on standard std logic vector. Okay, so here there is an example of this. So here now suppose we have a new type. New type is a either it is a 0, 1, z or x. Okay, these are the new type, that is the type, and then we are calling a function that is a NAND, which has the parameters left, right, which are of new type. Okay, and then it is returning to the new type. Then function OR, which is again using a type, that is a operators that are of new type, and then they are returning to the new type. So here if we have a signal ABC which is of a new type, then C which is assigned to A NAND B or X. Okay, so here we can go for the using the say operators that are of a different data type. And okay, so why to go for this overloaded function overloading? Because when we are using this overloaded subprograms and operators, it increases the readability of code. Okay, so that is the one advantage. Again, the result of using overloaded subprograms and operators, it is easier to read and maintain. Also, as I earlier said, that it frees the designer from generating countless unique names for subprograms and that do virtually the same operation. Then here the condition to overload parameters type of subprogram is that the base type of two parameters that must differ. If base types do not differ, then two subtypes are of same type, then in that case compiler will return to an error. Okay, and then by overloading an parameter, it is possible to perform the same operations on multiple types. Okay, that means suppose we are using a plus parameter, okay, that is addition parameter, overloading addition parameter that is predefined for arithmetic operation. But if we are using, it can be overloaded to perform the same for binary operations also. Okay, so here when we are using these operators, we can use these operators for different data types. So that is about the overloading of this operator. So remember that we can have subprogram overloading as well as operator overloading. Okay, so this is one of the concept that we can have in a VHDL programming. And after that, we are going to discuss about now delay. Okay, now whenever any designer that is writing a program in VHDL, there is a possibility to return a signal assignment after a certain amount of time. Okay, so that means we will not get the result uh, at the same instant when there is a signal assignment is there. Signal arrives at the input terminal. So, which implements the delay in the assignment. So that means sometimes we will not get the result output at the instant at we are giving a input signal. Okay, that means when signal is going from 0 to high. Our expectation is that at the instant the signal is going from 0 to high, the output should be go high. But this may not happen in each case, and it is having a delay in the assignment. So in a VHDL, mainly there are two types of delays. One is the transport delay and another one that is the inertial delay that are present. Okay, and again there is a one more type of delay that is a delta delay that also we are going to discuss here. So this transport delay that is used to model the delay which is introduced by wire connection or PCB connection. As there are so many components that are present in our design, so they are connected with each other with wires, okay, or there may be a PCB connection. So it takes time to get a result immediately, and that is why because there is a certain transportation delay that is present, and that delay is called as a transport delay. Then another type of delay that is a inertial delay, which is because of the analog part. That means the present devices that are present in the design. Okay, so it is analogous to the delay in the devices, which that respond only if the signal value persists on their inputs for a given amount of time. If the signal is present at the input for certain amount of time, then only there will be output that is present. Okay, so that type of delay that is introduced by the analog part that is called as a inertial delay. Now this is useful in order to ignore input glitches whose duration is less than that of the code delay. Okay, so suppose there is certain glitches that are present at the input port, and because of that a possibility of the change in the output level that is possible, and to avoid this inertially delay that is introduced in an analog port. Okay, so here this is the delay model which is present in a VHDL. So inertial delay, that is a default delay model. So that is introduced to avoid any glitches that are present. So this is suitable for modeling delays through devices with inertia. Now this could be for the logic gates, this or any another logic circuit. So this is useful for the pulses which are shorter than devices delay that are not propagated to its output. And then the transport delay, which models delays through elements with no inertia, for example wires. So remember that there is no any inertia in this delay, transport delay, all input events that are propagated to output signals. So any pulse, whatever may be logic level of that pulse is, so or how short it will be propagated, but it will take certain time uh, because of the wires, this transport. So delta delay that uh, is present because of the very small delay. It is a very small delay which is automatically inserted by the simulator to preserve correct ordering of events. Okay, so that means it is a very small delay to get accurate output at the output, so that whatever is the delays that are present because of the inertial delay or transport delay, that will not make out incorrect output, that should not get. So for that this delta delay is present. The delta delay is a special case of inertial delay with delay infinitesimally small. So inertial delay, here we have one example for this. So this is a default delay which is implemented in VHDL because its behavior is very similar to the delay of device. So this delay assignment syntax, that is like, okay, so if we want to get a delay, so for that we can have assignment syntax. So out one, okay, here you have this example out one, which is assigned to inertial input after 8 nanos. Okay, so that means now here we have one example of this gate. Okay, so AND gate. So one of the input terminal of this AND gate, that is a inverted, that means sorry, that is grounded, that means we will get output uh, when we will get output here, or what type of output we will get here. काय मिळेल आउटपुट आपल्याला इकडे, जर माझा एक टर्मिनल जर ग्राउंडेड आहे, that means at a zero logic, and another terminal that is going to vary. Actually this should be OR gate, then only this will be correct, but okay, we will that means what we want, whatever is the input present, that will be present at the output. Okay, so that type of condition that should be here. So here now we have saying that output should be present after 8 nanosecond. Okay, so that means whenever there is a change in the input logic level, after 8 seconds only there will be output is present. So this is the inertial delay of 8 nanoseconds that we are introducing in the output. Okay, so here now, though this logic level is changed, but as this is not present for 8 nanoseconds, so output will not change. Okay, whenever input is remaining at high logic level, okay, so after 8 nanoseconds only this output is going to change. Okay, and there will be a change in the logic level. Now in the another example, there we have introduced this delay of 2 nanoseconds. आता इथे काय होणार आहे, जेव्हा तुमचं इनपुट हे 2 नॅनोसेकंड्स पर्यंत हाय आहे, त्याच वेळेला तुमचं आउटपुट हे चेंज होईल. ओके, सो हियर दिस आउटपुट इज गोइंग टू change its logic level after 2 nanoseconds. So you can have this type of assignments so that you can introduce this inertial delay in a output. Okay, now you can instead of having this keyword, that is the inertial, you can just write it as also input after 2 nanoseconds. Okay, म्हणजे हा जो काही तुम्ही inertial हे word वापरला ते नाही वापरलं तरी चालणार आहे. It will have the similar effect. So that is the input after 2 nanoseconds. Also you can have the statement like it is a reject 2 nanosecond and then inertial input after 2 nanosecond. That means what now for this statement, what it will do, it will reject first 2 nanoseconds and then after that output will change after 2 nanoseconds. So this 2 nanoseconds that will get rejected. So that is the inertial delay. Okay. Then after that there is a transport delay. So here now this is a transport delay that is because of the wire. So whatever may be the change in a input that will be delivered at the output. Okay, though it will be delayed output but still output will be present. Okay, म्हणजेच काय होणार आहे, जर तुमचं A इथे आता 10 नॅनोसेकंड 10 नॅनोसेकंड नंतर चेंज होणार आहे and then at 20 नॅनोसेकंडला परत त्याची लॉजिक लेवल चेंज होती. Okay, so if suppose I have the statement that B is assigned to transport A after 20 nanoseconds. So that means I am having a wire delay of 20 nanoseconds. So once this logic level has changed, okay, at this, after that this output will change after 20 seconds, 20 nanoseconds, sorry. म्हणजेच काय होणार आहे, बी कुठे इथे लॉजिक लेवल चेंज झाली 10 नॅनोसेकंदला, तर त्याच्यानंतर 20 नॅनोसेकंदनी म्हणजेच 30 नॅनोसेकंदात बी ची लॉजिक लेवल चेंज. ओके, अँड देन इन दॅट वे अगेन ऍट 20 नॅनोसेकंड इट अगेन चेंजेस. सो ऍट 40 ला परत चेंज होईल. ओके, सो दिस इज अ ट्रान्सपोर्ट डिले. नाउ इफ वी हॅव a statement, yes, hello, anyone has doubt? If we have another statement, B is assigned to A after 20 nanoseconds. Okay, now here this transport word is not present, so it will be considered as a inertial delay. Okay, and then for the same input you will not get the result because actually inertial delay, okay, that is introduced because of the devices. Okay, now here as the input is not remaining for 20 nanoseconds at high logic level, so output will not change. Okay, and it will be at a 0 logic level only. So that is a transport, that is about the inertial delay. म्हणजे जर तुम्ही inertial delay इंट्रोड्यूस केला असेल करत असाल तर त्याच्यासाठी तेवढ्या वेळापेक्षा जास्त वेळ तुमचं आउटपुट हे त्या लॉजिक लेवलला असलं पाहिजे, तरच त्याचा इफेक्ट तुमच्या आउटपुट मध्ये दिसेल, अदरवाइज तो नाही दिसणार आहे. So that may create a error. Now another type of delay, that is a delta delay, which is a very small delay and that is introduced in the output so as to get a correct output. Okay, so here now we have this example. Okay, so a very small delays that are introduced at each of this inverter. Okay, so these inverters or NOT gates that are used here, as here actually Y is assigned to not C. That means whatever is the C that is present, inverted output will be present for the Y. So C is not B and B is not B. So each of this gate that is introducing some of the delay. So here you can see that this B will be at high logic level once after certain delta delay. Okay, similarly C will be change its logic level after some delta delay and then this will be changing after some delta delay. So actually, for output Y, there will be if effect of all these delta delays. Okay, so they are very of small time, but still that will be present in the output. Okay, so that is the delays that are present in the VHDL programming. Okay, so this is the summary of this uh, delays. Okay, so I will not going to read about this, but this is all about the summary about the delay models that are present in VHDL programming. Okay, so here almost all the basic components and all the basic things that we have cleared for the first unit. Okay, so if you have any doubt about this, you can ask me. Okay, again I am telling, start writing your assignment. Okay, and finish it and send me your scanned assignment. Okay.
Okay, ma'am.
Okay, so we will stop for today. In the next lecture we are going to start with new unit. Okay, if you have any doubt, then we can go for that. Otherwise we will start with the next unit. So now we have just finished a basic part of this VHDL programming. In the next unit we are going to see about how we can write program for the sequential as well as combinational circuit. Okay.
Excuse